And welcome to another exciting Java class. I'm going to try and discuss a little bit about the new homework assignment which I have in store for all of you. I've already posted it onto Mentor, and it is here. I'm in the process of changing it a little bit, but it's called the duplicate file problem. Now, in the duplicate file problem, you are presented with two completely different directories that look very similar but have different files in them. And your goal is to create a new directory, call it the output directory, which contains all of the files that are in the two input directories. If there are two files which are identical, you take the most recent file. That's all. Now, to do this, you need to recursively traverse the file system in order to be able to start at the root directory for the directory number 1 and start at the root directory for directory number 2. Then you need to list all of the files in both with dates and merge that list so that only the most recent files appear. And then you have to create an output directory, and it's all due in 1 week. After you finish your code, you need to put it in a package. The package will have your last name on it, and then you will zip the package up and upload it into your Mentor folder. Every student should have their own Mentor folder. Does it make sense? Yes. It doesn't matter if the files are the same or not. If there are no duplicate files, then directory 3 will contain the output from both. If there are directory files, then the collision will be resolved by selecting for the most recent file. So it is the case that you will find files that are duplicates in general, and then you'll have to decide which one is most recent. We'll do the decision based on modification date. And so we need to select a file and find out what the date is, and then we have to determine if the other file that is like that file is modified after or before. So if it's modified after, then it's a more recent file. File absolute path name, because you could have two files with the same name in different paths. Those are different files, but in general, if they're going to go into the same directory, then it's going to be a collision, and then you have to decide which file to use. So it makes good sense to start by listing all the files in a directory. And I think it would be very good for us to have a plan of attack for this problem. So the first thing I would like to do is write a program that allows the user to select a directory, and then it will print it. And then I would write a program that takes that directory and lists all the files and recursively through that directory. Then I would like to modify the program that lists all the files and add the dates, the modification dates. And once I have that done, I think my time will be up, and it'll be ready for you guys to finish the program and give us some sort of an answer on how to create the merged new file. A lot of times we have two different folders with different versions of programs or files or lectures. We need to merge these things. This is a utility that will help you to do that. So it's a truly useful utility. The class has already begun, so you're 7 minutes late, and I already described the homework which is due next week. I outlined homework that basically takes two input directories, recursively traverses them, scans them for the date last modified, and then creates a new directory called the output directory, which is going to consist of unique files. So when files have collisions, you have to select for the most recent. And what I'm planning to do now is show you how to recursively traverse the file system using Java, and then we'll use that program to try and get modification dates on the file. And based on that, you should be able to wrap up the code and deliver it electronically in a compressed zip file, in a package, to Axiom by next week. So that's the basic idea. I also have additional books in case some people didn't have a chance to get books. But unfortunately what has happened is I have not been able to get them at the same low price that I sold them for last week. So now, you were right, the price did go up. Now they're $30. This is terrible, I know. But it didn't get cheaper, it got more expensive. I ran out of books, I had to go buy them. So that's why. So if you need a book, I have 3 left, and that's all I have. Anyway, getting back to the problem at hand, I've uploaded this homework into a homework calling the trial file. And what we're doing in this particular exercise is what I would call a basic utility in Java, which will just get our feet wet with Java and get us doing a little file I/O. So I thought that would be a nice exercise for us. So let's start by learning how to recursively traverse the file system in Java. I think that would be a good idea. So we'll start with a utility that I've already written, and it's in my file utilities package. And this is called futils. Like Star Trek, resistance is futile. So the futils contains a series of different file utilities which allow me to, I'll say, conveniently manipulate the file system, for lack of a better term, I guess. And inside of the futils package, I have a class called dirList. And what dirList does is it lists recursively all of the files in a directory with a difference. And the difference is it has filters which allow you to select how to create the list. So if you wanted a list of only files that ended with Java, for example, it would do that. If you wanted a wildcard, so it said anything that includes, let's say, dir in it, you could say star dir star .java, and it would find all of that. So it has a way to do a little pattern matching as it builds the list. You can delete all the files in the list, so that can make this an exceedingly dangerous program. Don't delete all your files. If you're a beginner and you're not sure, it's very bad. In other words, I had a idea that you could just take 2 directories and merge them by destructively synthesizing the output and the input, a program that alters its arguments. That's very dangerous, too dangerous for a class project. So instead what I did was I say 2 inputs, dir1 and dir2, and then a new directory, dir3, will be the output. So we will not destroy any files which we are selecting for the input. That's sort of important to point out. Don't delete any files with this program. You're just learning. It's very bad. I don't want to hear, "Oh, Professor, I ran your program and now I have nothing on my C drive." that would be bad. Don't do that. So Duralist, yes. Let's describe what Duralist does. What does Duralist do? So Duralist has an interesting set of what I will call constructors, overloaded constructors. In this one, we use the suffix in order to be able to establish the list. So if the suffix is a string and it ends in Java, this will give us a list of everything that ends with Java. It uses a series of, I'll call it, polymorphic interfaces that implement the file filter. So, for example, when we look at the wild filter, what we see is that wild filter is implementing the file filter. And the file filter interface requires that we accept a file under some condition. We do not know what that condition will be. You can make it as complicated as you like. All we know is we're getting binary information about the file as it comes in. We'll either accept it or we will not. So when you go to create the regular expression for unifying with the string representation of the file, you will be able to implement the accept in as arbitrarily complicated a manner as you like. What I do with my wild filter is I allow for wildcards. And wildcards can include a suffix, a prefix, or a midfix, where a midfix is any string that is contained by any other string. And so when I build the accept clause, what I do is I determine if you're going to input the suffix, prefix, and midfix. And so here, when you build the wild filter, we can establish the suffix and the prefix. Or if you build the wild filter, you could have a prefix, a midfix, and a suffix. And the accept will always check to see if the suffix is null. If it's not null, then it'll use it. If it is null, it'll determine what else is available. If the prefix is null, then it won't use prefix, it'll just use ends with. It'll just say, oh, if it ends with the suffix, then it's good. If the prefix is if the suffix is null, it'll look at the prefix if the prefix is not null. And that will say, look, if it starts with the prefix, then we'll use that. And then if you've got the midfix is null, then what we do is we just look at the ends with and the starts with. Otherwise, we look at ends with, starts with, and the midfix index of being non-negative. If the midfix index of is non-negative, that means it exists in the string, and we found it. So the accept clause, which is here, can be rather complicated in its implementation in terms of logic. And the wild filter lets you select for files that either start with or ends with or have inside of a wide combination of different strings. The reason I call this a polymorphic filter is because of its implementation of the file filter interface. So the file filter interface is one that's recognized by the Java I/O package. It's used in the JChooser dialog, so it can restrict the list of files that you may encounter. And you can certainly use it in your Durlister when you go to create lists of files. So when you're aggregating large lists of files, if you said, geez, I want to delete all the files that begin with a dot because those are invisible and they end up being artifacts from Macintosh operating systems that I don't want, which is true, you could go through, create the list of dot files, and then just delete them all at once. Of course, you might like to put a confirmation dialog box up there first that lists all those files and say, are you sure you want to delete all these files? Because if you're not, you shouldn't do it. So there are certain things you might want to be careful about. Does everybody sort of understand about polymorphism? Poly means many, morph means shapes. You guys have all had object-oriented design, so you know about this stuff. So back to the Durlister, I'm using my little wild filter in here, and it looks like a little thing with nothing behind it, but in fact there's been a considerable amount of effort and thought that has been placed into the wild filter. What about that read dir? That's complicated. Yeah, you thought wild filter was hard. Read dir is even worse. What read dir does is it returns a directory selected by the user. You want to get a directory open for read. Well, what read dir does, what does read dir do? What read dir does is it uses a JFile chooser in order to be able to open up the file, let the user do the navigation, get an approval, maybe select files, and then do a return. And it'll return null if somebody cancels. So if you don't check for cancel, you're going to throw some sort of file not found exception at runtime, I/O exception at runtime. So this is not necessarily the nicest way to implement it, but I've been using it for some time now. So there's my dir lister. That'll let me get a file, start point, my dir, my initial directory, the suffix where I might be looking for stuff, and dir lister will let me pick a start directory and the file filter, so I've got it overloaded, and I can even show a progress dialog box. What do they call this? A progress bar. So I put in a nice little GUI just in case you're thinking of navigating through the entire root of the C drive, because that will take time. So you want to, if you're ever at a point where you're designing a graphic user interface and you're thinking that you're going to let the user hang around for a few seconds or more, it's really nice if you can put up a progress dialog box. I forget exactly how many seconds it is before it's impolite, but anything over 5 seconds I should think you'd like to say, oh look, we're really working, we're not just hung. Because otherwise users tend to click more than once and they go, it's not working, and you have to say, oh, you have to be patient. Well, that's the progress dialog box telling us to be patient. So the other thing I'd like to do is sort of run this. I've got a little program in here. Let's see if I can run it. So he says select a root directory. I guess I'll select J4P lectures, hit open, and it lists everything. So this is giving me what's called a fully qualified file name. A fully qualified file name includes not just the file name at the end, but all the stuff that comes before it in order for the file to be uniquely identified in the file system. So no two file names should ever be the same, but if you're comparing two directories, you may want to compare it from the root of the directory, but not necessarily the root of the file system. So if I have two different file folders, one is called folder 1 and the other is called folder 2, and they contain similarly looking files, when you do the compare, you're just going to want to start from folder 1 and folder 2, not from C:, not from all the way up top. So you'll have to decide what makes sense. For me, it might want to be starting from J4P lectures, not starting from Dropbox. Because I could have two different folders in Dropbox, but what I did was I started with J4P lectures. That's my root. Now if I go to find a second directory, it might also look like a J4P something or other. For example, here's a J4P, and there's a J4P. Two different directories with two completely different files in them. If you're going to merge them, you'll need to be able to select both. But when you decide which one you're going to keep, you're going to end up having to navigate from just the folders that are selected. So if I start from here, I get a rather different set of files. This is not the same file set. Am I making any sense yet? Good? Okay. The files are stored inside of a vector, and you can go into the dir list and you can get the list of files directly. You can add files one at a time. You can add a whole bunch of directories if you like. You can get the start directory, which will give you the route from the place where people started to do the navigation. Let's see now. You can get all the bytes that you've seen. You can get a list of how many files there are in your vector. You can get an array of file type, a homogeneous set of file instances that you could then traverse. So in some sense I could claim this does a great deal, right? This is a fairly powerful tool. It takes care of a lot of the problems that you might have if you were going to build your own tool from scratch. Do you have to use my tool? No, absolutely not. But you might want to at least consider it. If you've already done the build, maybe it's not that hard to use the tool. Did everybody have a chance to do the build? You built the code for the course code, J for P, in whatever IDE you selected, Eclipse or IntelliJ. That was kind of a work it on your own kind of homework assignment. Did anyone have any trouble doing the build? No issues? Nothing? I should just run through the attendance list. Deepa? A rule. That you're a rule, okay. Sushmita? And Sarah, right? Sarah. I'll learn your names eventually. And I'll say hello to Jose and Stefanos. They're distance learning right now. Hi. You can see me waving, right? So it is the case that there were a couple of things that I wanted to point out at the beginning of the class. One of them was that I have the assignment already uploaded into Axiom Mentor. The problem statement. 2 directories go in, 1 directory comes out. The directory that comes out has the most recent set of files. If there are no overlaps, the number of files in the output will be the same as the number of files in both input directories. So if the input directory has 50 files for directory 1, and the input directory 2 has 50 files, and the output directory will have 100 files, assuming the input files do not overlap. But if they do overlap, you have to take the union of those 2 files and decide by disambiguation which one is most recent. And then you just keep the most recent file. And remember, don't delete files. Okay? So the next question is, now that we know how to get the big list of files, how do we get the date a file has been modified? That's very important. So I have sort of an answer for this. I googled it myself. It says file. I get file.lastModified, and then there's a nice way to actually format the date. And so if last modified is something that we can do, then it might make sense for us to make a file, select it, and determine when it was modified last. Then check that date against what Windows tells us. So I'm sort of interested in this. I've never quite done it myself. Here I can go and get a file list, and this will print the files, but I've never actually gone through the files to determine when they were last modified. I think that's an interesting idea. So what would happen if I went through the file list, and I suppose I could just write a program, right? Suppose I said something like this: for integer, whoops, thank you, IntelliJ, integer I equals 0 while I is less than fa dot length, enter, I plus plus. So I'll iterate through my big list of files, and I'll say something like this. fa of I dot last modified. Sounds simple enough, and I don't know exactly what that's going to do, so I'll just say sout control J enter, oops, control J enter, and then maybe I should put the file name in there. fa of I plus quote last modified IED end quote plus, and then I need another end parenthesis, and what does that buy me? Kind of a mess, really. I need to clean it up. Maybe I don't even have to put in last modified. I'll just put in the date. Oh, I have a better idea. How about this? Why don't we, since the dates are all going to be formatted the same, I'll put the date in first, and then I'll put in the I'm sort of doing this on the fly. Plus space quote there. How's that? And I don't need this anymore. So my fancy program. It has for loop, goes through each file, prints out the file, fully qualified last modified date and file name. What could possibly go wrong? We'll start with books and see what happens. Open. Okay, so this is an interesting thing. That doesn't quite look like any date that I know, but maybe that's how dates are formatted. So I think I'm close, but not quite. I'll use my fancy simple date format thing, which gives me hours, minutes, seconds, and month, day, year. I'll copy that. Probably only need it once. And then Alt Enter to import, and then I'll say something like this: sdf.format, and then I'll put in the date, and maybe I should spell format right. Format. How's that? Oh, this needs a semicolon. What else? What could possibly go wrong? Okay. Yeah, that sort of looks like a, I don't know, dates. Looks like dates. How do I know if this book was modified after that book? Or how do I know which file is most recent? Well, I could check, I check the dates, and maybe there's something about dates that allow me to determine if something is after something else. So last modified probably returns something of date type. Returns a long, actually. So if I know when it was created in milliseconds, then in theory that must be some time after, let's say, 1974, whatever it is the computer uses as standard. (1970). So it's milliseconds since 1970. So presumably your Java program was written after 1970. I think that's a good assumption, because they didn't have Java then. What did they have? C? Fortran? B? They had B before C, right? BCPL and B and Snowball and Algol. Not Pascal, not yet, not till 1971, I think. So it's a yeah, it's an interesting point. This should work. Let's see if we know enough now to do this assignment. Two directories, directory 1 and 2. Create a new directory. So copying a file. Now that you know about the list of files and you know when they were modified, can you copy a file from one place to another? I think that should be pretty simple, right? I have an example in case you want to see. It's in the book, and I believe it's under Files, and here is a way to copy a directory, and it will give you an input directory and some files in the directory, and then an output directory. And let's see, somewhere in here I think there's the business end. Yeah, this one is using a reader instead of using a simple I/O stream. If you're going to copy binary files, you'll probably want to use a file input stream and a file output stream, not a reader and a writer. So this is using a file reader and a file writer because it's assuming that you're using characters. But if you do something like that, it's going to corrupt the files. And that's not something you want to do. So if you want to do a file copy without going through readers and writers, would you be able to? Right? You need a binary file copy. You cannot just use a character file copy. It's not good. So everybody understand why this would not work? Readers and writers are for characters, but for arbitrary file copy, you must use binary data. You need a file input stream and a file output stream. Do you need to see a binary file copy? No? Okay. I think that's probably going to be in here anyways, in case you needed to see it. Let's see. Readers and writers. I could do it. I'd have to write it. But I assume you guys can do a binary file copy on your own. Is that a safe assumption? Yes. Okay. Good. Then that's fine. What do you think about this homework? Is it doable? Seems easy enough? You want to ask any questions before we move on to other things? No? Oh, well, if you use my dir lister, it comes with enough of a GUI to give you, you know, the interface. So, in general, you know, you could, well, I leave it to you how fancy you want to make your graphic user interface. You may, in fact, like to create a nice dialog box with text fields that show the actual path, and then gives us a button to change the path. But the way I did it was I used a file open dialog box to select the directory, and I use a file save dialog box to select the output directory. So based on those 2 or 3 dialog boxes, I have sufficiency. On the other hand, it is possible to create something a little bit fancier if you like. I have, I think in my directory copy example, I show something a little bit different. Let's see. Select the source directory, select the target directory. Yeah, so that's a little bit more fancy. I've got a source directory and a target directory. If I put buttons next to this, I could probably change them. I could do a search and replace to create a new output file if I like. I mean, it's just sort of just copy and don't do replace or whatever. So I guess you could make a fancy GUI. It wouldn't stop you if you like fancy. Fancy is good. What else? Any questions? It's a simple assignment. If you're wondering where we are in the book, chapter 15 is streams, and I/O streams, binary file copy, that's all in there. So we are probably just wrapping up file I/O. How about this idea of doing gzip files? Does everybody know how to make a compressed file? Take an input of, let's say, a list of files from a directory and make a single compressed file output? Does that sound educational? Gzip output stream? Have you not seen that before? Here's what I'll do. Let's create a program that inputs a list of files and then creates a single output file called the gzip output stream. Does that sound educational? I'm not feeling the love here. You have to fight the Facebook like with Facebook love. Right? This is sort of one of those things where I have a few examples which I could show you, but it's sometimes better to write something from scratch. So what I'll do is I'll create a new Java class which I will call the gzip example. And what we'll do is we'll start with a little main method, and we'll get our little dir list, and we'll make it so that it always gives us all of our Java files. So this sounds like a useful thing, right? And we'll start with the suffix .java. So anything that ends with a Java is interesting for us. And then what we'll do is we'll need to give it a start directory. So what we'll do is we'll say something like this: feudal dot get read directory, and we'll select our source code, because I'm going to compress all the source code in my program to create a new output file. But first, what I'd like to do is I'd like to make sure I got all the Java files for the I'm going to write a program which will effectively compress itself. So it's a sort of, I'm going to go through and list all the files in the program, including the file that's listing itself. And so what we'll do is we'll say something like dr.print get files, and then we'll go to the print utils, hit print, and this should list all of the files that end with Java. How's that grab you? Does that? What about this business about print utils? What does that do for me? Well, print utils is just a way to print stuff. It takes a whole list of objects, and then it goes through and prints each one. So I find that just very convenient. I don't want to have to keep writing for loops all day long. So I just call printutils.print and pass whatever, and it does the right thing. Little convenience utilities like that make the Java seem to go so much faster. So if I run this, it should prompt me for a read directory. It says select source code, so I have to go find my source code. Let's play find the source code. I don't know. Could this be it? I think this is it. Probably. No, that's not it. It's got to be in here somewhere. Probably in Dropbox. Oh, code. Yes, of course. There's the source code. We hit open, and now it's just sort of... Is it doing anything? Maybe it needs the progress dialog box. It seems very slow, or maybe I'm doing something wrong. Should I just be patient? Is this one of those you gotta be patient things? I know there's a compelling argument. Oh, there it is. So now you can see why progress dialog boxes are so important. Right? Because I was about to quit and say, oh, it's broken. I did something wrong. But I didn't. Well, actually I did. I didn't use the progress dialog box, which I told you to use. So do as I say, not as I do. So probably there's another way to do this. Progress dialog box. Let's see. I need a start directory, a file filter, and then I can put in the progress dialog box. So if I create a wild filter, WF equals new wild filter, and the argument is a suffix quote .java end quote sem. Now I can pass the wild filter in here, and I can type Control P, and it'll tell me I can also put in a progress dialog box. I'll put in true. And then I ask, what could possibly go wrong? I have no idea. So let's just hit open. Look, I had progress. It actually ran much faster that time. I didn't need the progress. Wow. Why did it run so quickly this time and so slowly before? If before I would look at it and I'd say, gee, no one should ever use Java ever. And then I use this, and that's pretty good. That was nice and fast. And it's only files that end with Java. So that's very good. And I have a nice list of files, and now I have to pack them. I have to pack them into a gzip output stream. Ooh, tricky, right? So I guess the first thing I need to do is to create a what you might call a file input stream. Oh, I need to go through each file, read the file into the file input stream, then make a gzip output stream and write the file out to the gzip output stream. So I need like a for loop. So file array equals dl.getFiles, and then alt enter, and now I have to write a for loop for integer I equals 0 while I is less than fa.length, I plus plus, and now I'm going to have to create a file input stream from each file. Read from each file one at a time. So I'll have to do something like this. File input stream FIS equals new file input stream, and I'll have to read in FA of I, and now he's giving me a hard time. What's his issue? Exception to method signature. There we go. Yeah, a file not found exception is a caught exception. If you remember, there were two kinds of exceptions, caught exceptions and runtime exceptions. Caught exceptions, you either try and catch them or you throw them in the calling block. So I threw it in the calling block. So then, what would be a good thing to do here? I need a file output stream, and it has to be built from a gzip output stream. So if I do this, if I make a gzip, I first need a file output stream, so let's get a write file. File, this will have to be the write file. So write file equals feudal.get write file. And this will be a gzip file or a zip file, whatever you prefer. Shall we try gzip, or maybe zip is good? Select a zip file or a jar file. Jar files are good. Oh, I've already used wild file. This is to be a write file, so let's call it output file. Output file. And so we'll get the write file, and this will be whatever you like. Zip, gzip, zip. Here's zip. Oh, I know. Select a zip for output. Very good. Then I guess we could try something like this. Zip file he says I got choices. Oh, I use this one. ZF equals new zip file, and he wants the file, so that'll be the output file. Now what's his problem? Some kind of exception, I imagine. Yes. IO exception. So now I got the zip file. So now what I want to do is I need to add an entry to the zip file. How does one do that? So let's see now. Get name. There should be like a way to set the name. Or set the entries. But I'm not seeing it. So in a case like this, since I haven't done zip file in recent memory, I'll just say zip file in Java. Let's just see how they do it. There's got to be a prototypical example. So let's just say example. Usually I think about gzip output streams or jar files. I don't really do zip very often. I was thinking of doing a jar file too. If I said jar file, what would that buy me? Copy, jar file. And now if I said JF or instead of ZF, would that do me any good? It should be able to set the jar entry. Let's see what he has to say for himself. There really should be like a nice, I got the file output stream, new file output stream, zip archive, that's fine. Zip create, zip file output stream. You have to do a put next entry. Copy. That's not too bad. So if we go back to zip file, call it ZF, zip file, Now we're there. ZF dot put next entry. Now what's his issue? Import class, zip entry. And the file name is going to be FA of I. Now what's his problem? Oh, you have to convert it to a string? Yep. And now what's the issue with the entry? The zip output stream. So a zip file is different from a zip output stream. This has to be a zip output stream. Output stream. That was the problem. Key. Now what's his issue? Alt enter. We're there. Now what he... Ha! If it's not one thing, it's another. He doesn't like file. He wants file output streams. So I have to say new. Here, we'll make a file output stream for him. File output stream FOS equals new file output stream. Put in the output file. Alt enter. Put the file output stream into the zip output stream. You got to do everything right. Do it in the right order. So first you create the file output stream. That's going to get closed and flushed when you're done, or you will have a corrupt zip file. The reason why is because a zip file, because of its compression, has to create a dictionary. The dictionary contains different string patterns. Each string pattern goes into a code word. So the dictionary must say, if I use the code word string 1, S1, then it expands to this. If I use the string S2, it expands to that. Right? So the dictionary is just a big lookup. Once you create that dictionary using a code book, essentially, you have to transmit that dictionary, and it has to be transmitted in an error-free fashion. Because if the dictionary is corrupt, the file will be rendered unreadable. So it's very important that you flush the file in all output streams when you're done, or this will never work. Then when you put your entries, you got to put them based on the actual, I'll call it a fully qualified file name. And then after you get the file name in there, you've got to put the data that is associated with the file, because you're constructing a file system in a single file. That one file, that zip file, contains not just the data, but also the name of the file where the data resides. So that's so important, or else you're going to have a corrupt file. So then after that, you can take your file input stream, you write it out, and close your entry, but you're going to have to go to the next entry when you're done. So this is a sort of a, I'll call it a little fragment. You need a buffer. For the buffer, he creates a little buffer, 1K buffer. That's fine. So we'll use a 1K buffer too. I only need that once. For my zip output stream, he has I use zip file here. I guess I can call this ZOS like he does for zip output stream, and then I can do ZOS put next entry. And what does that buy me? Pain, right? Because why? Because I never close the file. And what about some kind of progress dialog box? Do I need progress? Maybe I could print out the file name as I go. How about this? If I mod 10 equals 0, then S out, Control J, enter. Compressed. Oh, I see. You need a quote. Compressed file number end quote plus I. So every 10 files, it'll just print out a little progress on the console. I could get fancy and make a progress dialog box that marches across the screen using swing, but that would defeat the elegance and simplicity of my example, which has become rather involved, actually. Oh, and what do you do when you're done with your output streams? Close them. Thank you. So, Professor Lyon, you forgot to close your output stream. Thank you. FOS.close. And we have a saying in summer camp, FOS.flush. Flush twice, it's a long way to the kitchen. FOS.flush. Actually, it doesn't matter if you flush twice. And really, it has nothing to do with the kitchen. So, let's see if we can make this work. Right, yes. Why should Java be in such bad taste? Yes. Oh, the one I just wrote? Oh, well, this is part of the code for the course, and what I did was I sent the Dropbox link to everybody, but I'll do that again, just so that you guys can have it. You don't have the code? I thought that was going to be something you guys would build as part of the homework from sort of the do-it-on-your-own homework from last time. But I'll make sure you have it. Let's run this program first and see if it works, because I'm very anxious. It says select a zip for output. It ran very nicely. It ran nice and fast. I wonder if it's correct. Let's give it a good name. foo.zip. Save. Compressing. Oh, I forgot to print done. Is it done? I don't know. I should call system.exit of 0 or print done or something. I think so. I think it might be done, but maybe it isn't done. It looks done. It looks done. I think we need to print something. How about if we stop with the flush nonsense and then do something like S-out, Control-J, enter, quote, done. That just makes me feel like it's done. Then I will know. Let's just run this again. Okay. And what's the output? We'll overwrite foo. Yeah, we'll replace it. I don't care. And he goes in here. Then he's done. Done. So now something was left here. Foo is here. And if I open it, ooh, cannot open. Really? Oh, how awful for you. You've created a corrupt zip file. Not correct. It was so promising. I had so much hope for this zip file. Did I do something wrong? Obviously. Obviously I did something wrong. What did I do wrong? It seemed so innocuous. You know, just for a good time, I'm going to check to see if oh! How about that? So it made a jar file that the jar tool could read, but the file compressor that it used was not compatible with 7-zip. Oh, 7-zip probably wants 7-zip files instead of regular zip files. Maybe that's it. I'm not sure why But I mean, it clearly had all the stuff in it, right? And let me just sort of check, because I'm feeling very uneasy about this. Where did it go? You know, I think it put in the file names, but it didn't put in the actual files. Is it possible I didn't properly close each Oh, I should just get the file name and not the fully qualified file. Oh, maybe. No, that doesn't make sense, because the file names could conflict. They might be two names with the same identity. Maybe I should have started with the start dir and started there. There's something fundamentally wrong here. I agree with you. ToString doesn't seem like the right thing. What if we just did get name? I don't feel confident that that is a correct approach. Let's see. Put next entry. ZOS right. Something is wrong. Let's figure it out. It just seems like it should be working. It's not rocket science. I don't like to waste class time debugging little things like this, but it should work. I think if I use jar output stream, it would be no trouble. And certainly it would be easy enough to change. So, to answer your question about the code, if you go to Dropbox, if you can go to Dropbox, here's the code. Share link. Copy. Close. And I'll just paste it in here. Edit. So it's in the so-called homework, such as it is. Why this feels like it needs to recompile everything, I do not understand. There's something terribly wrong that it should have to recompile the whole project. Did I do something? Did I do that? What is happening here? That's bizarre. I just wrote it out to foo. Is it possible it... Oh! The jar file overwrote all the existing source code. When I did jar -xvf, it output the whole thing using fully qualified file names. Oh, that's very bad. Right? Because look what it did. It inflated it out to Dropbox source code. It didn't put it into the relative file name. So when I did the jar -xvf, it just overwrote the whole project. Wow. Wow, look how dangerous it can be to write little Java programs that seem innocent. Oh my heavens. Yeah, wow, because it inflated to a fully qualified file name. That could have been a disaster. Actually, it is sort of a disaster. Wow. So when you do zip, you need to do relative file names instead of fully qualified file names. Oh, I better put a warning in there about that. Yes, yes. Makes perfect sense to me. Right. dangerous program. Uses fully qualified file names. Files. Bad, bad, bad. Don't do this. Whoa, it's a good thing I'm doing it on my computer and you're not doing it on your computer. Because that would be... Actually, it's really very good for me to make this mistake in front of the class. Just think of how educational it is that you're not doing this on your own machines and wiping out your C drive. Just think of how happy you are to be here in lecture today, to watch me screw up my computer so you don't have to screw up yours. Thank you, Professor Lyon, for screwing up your computer and saving us from doing it to ourselves. Yes, quite right. So you need, if you're going to modify this program, don't use fully qualified file names here. FQFNs, fully qualified file names. That's a good one. Yep. Yep, I could see that. Very bad. Right? Because the file input stream obviously is going to give me a... See, there should be a way in the dir list to get relative file names. That would be the thing. So the dir list shouldn't just get me the files, it should give me all the relative file names. See, I don't have that here. That'd be a good one to do. Relative file names. Well, I know the directory. It will give you a file name, but if two files have the same name but are in different directories, then you'll have a conflict. That's what I was doing here to get the name. But that's not correct. What you want to do is you want to get the relative file name. That's so important. So when you go to create lists of files, you better use relative file names. That's key, very key. That's kind of a to-do. We could almost make that a another project. Relative file names. Yeah, because when dir list goes to create a file, a list of files, it creates absolute path names, not relative path names. That's very important, and it's not a very easy change to make. You could do it as a pre-process, or you could do it as a post-process. Since the dir lister already exists, I would suggest that we do it as a post-process, but not now, because it's too time-consuming, especially if you plan to do it right and go through a debugging, because it gives you the start directory. We have the start directory, so all I really need to do is strip out everything up to the start directory, and then from the start directory on I keep that. So if I get index of the start directory, I should be able to get the substring that starts there and ends at the end, assuming the start directory doesn't appear twice, and it shouldn't. So then I'd have to call a processing routine before I went and called get dir, get relative files. Very good. So what an innocent looking program, and it could cause so much damage. I wonder if I can compile anymore. I still have more compilation to do, because compiling this project is kind of a big deal. So while it's compiling, I have a great idea. Let's take a break. It's a good time for a break. And then by the time you get back, this will be done compiling.